Hello, everyone, and welcome to the Skywalk Podcast. My name is Gavin, and I will be your host for Season 2, Episode 2 of the Skywalk Podcast. Today's stories: have we discovered evidence of life outside of planet Earth? A new black hole that was recently observed was seen eating an entire star. And a Chinese rover on Mars is stuck in hibernation. Will we ever see it respond again? This is the Skywalk Podcast. I don't want to be a broken record. I know that we went over this in the first episode, but I do want to reiterate very, very quickly all the points that you can expect in this new season of the Skywalk Podcast. And I probably won't repeat these again after this episode, but figured it's nice to have it a second time. So, very quick bullet points. Here we go. Number 1. There's a vodcast and a podcast. So you are watching this now, it means you have found the video. But for those that have not, there is a video coinciding with this podcast episode, and that will be found on YouTube under the name Zombefied, Zombefied. And if anyone is watching live, this is also how you can participate in live episodes, is by joining that YouTube stream. Number 2, there's a new format. And so here's how these episodes are going to go: space news, object of the week, Q&A, and picture of the week. And then we'll wrap it up at the end. Number 3, there's new socials. So subreddit Skywalk Pod, there's a Discord server, and a TikTok channel, Skywalk Pod. And there's also a website now. So the subreddit and Discord, that is where you can start joining the community, talk with each other, interact, post things, yada yada. The TikTok and the YouTube channel with YouTube Shorts is where you can find like 45-second to minute-long bite-sized versions of space news that we'll do in each of these episodes, along with other supplemental material. Just this past week, we talked about the comet that is visible right now for you to see, as well as the possibility of life in the universe, and a brief history and overview of telescopes. And so, number 4, new merch. Yes, there is merch to go along with this podcast, and you can find that at The Graveyard. And so, The Graveyard is the merch site. Again, there will be a link for all of this stuff down below, and there might be about 1 or 2 more days left, or it might be over, for the 10% off coupon using code SEASON2. I want to make sure I spell this right. SEASONTWO. That should be up for at least a little bit of time once this episode goes up. And that's for 10% off all merchandise. All right, guys. That is our overview of all the previous stuff that we spent like 10 minutes going over last time. We're doing a lot better this time, about 3 minutes, which isn't too bad. And so that is our overview of everything I have for you right now. Of course, I'll keep you updated as we progress and as I have more news. But I do want to just say, guys, I really appreciate all of your support, especially with the YouTube Shorts. There's been pretty low growth on the podcast and on this YouTube channel over the last couple years. But ever since I started posting those shorts, you guys have been eating them up. Tons of views, tons of likes and comments, and a lot of new subscribers joining this community. So I just want to say from the bottom of my heart, thank you guys. It means a lot, and I love seeing this community grow. Don't care about all that fame, money, all that kind of stuff. I just want us to be able to have some fun. Have a nice little community that I can talk to and share all of this information. And so, again, thank you guys for all of the love and support recently, as we've kind of revamped this whole series. I've been putting a lot of work into Skywalk. With all of our housekeeping things out of the way, I'm Gavin. I am your host for this podcast, and it is time for us to embark on our journey through the stars. So sit back, relax, get yourself a hot drink in this cold weather, and your very own soft cookie to go along with it. And as always, guys, star cookies get bonus points for that. And now that we are all settled in and ready to go, let's jump in to our big stories of the day. All right, let's jump into our stories. So, a UK meteorite possibly contains the building blocks of life. In 2021, a meteorite crash landed into a driveway in I'm not going to be able to pronounce this right, and I apologize ahead of time. Winchcombe, England. It's a town about an hour and a half south of Birmingham. And so a meteorite was found crash landed onto a driveway, and I say big meteorite crash landed. It's like it can fit in the palm of your hand. It wasn't destroying your house level. But it was very quickly collected after its landing, and so scientists began their work. They started seeing what they can learn from this new piece of space debris. And after analyzing the rock, they have just announced that they have discovered the possibilities of the building blocks of life just in this little rock. And so they discovered both amino acids and evidence of liquid water that were both on this meteorite. And amino acids currently on the meteorite, which is absolutely incredible. Admittedly, I am not a big bio person, so I had to actually look this up a little bit to try to figure it out. Amino acids are known to be the building blocks of life, but more specifically, the beginning steps of building DNA and also reading DNA. And so that's where you get all the letters, abbreviations mixed together with the proteins, yada yada. Stuff that's a little over my head because I'm not big into biology and chemistry, but basically you need amino acids in order to have life. And we're seeing this along with other organic material on this meteorite, which is absolutely incredible. And that points towards the possibility of prehistoric life. Sometime before current age, there was possibly life on wherever this rock came from, on the original asteroid that it came from. These organic materials, they also noticed, are certain organic materials that dissolve easily in water, and they saw them dissolved. And so there's that and other evidence linking that they think those also liquid water once around and on this meteorite, which is again mind-boggling that was just floating through space, because kind of this is what we're hoping for. This is possibly the smoking gun that we are looking for to prove that life could be elsewhere in the universe. And this is just helping us have that motivation to keep searching for it, because we keep seeing these little hints. And it can also help us peek behind the curtain of how the Earth formed and how life started on Earth. Following the theory of evolution, it had to have started from somewhere. And so one thought in theory is that a meteorite, such as the one that they just analyzed, could have a very, very long time ago dropped things like amino acids and water and yada yada on Earth, and then evolution began and built life from those building blocks. And so, again, if we're seeing this now, well, there could be other life there, or it could have happened before, it could happen in the future. It's just really, really exciting that we're seeing this now. And they also have ruled out any contamination of modern amino acids being on it because of how quickly they collected those samples off of the driveway. And so they've calculated it's within a reasonable amount of time that it shouldn't have been contaminated with anything here on Earth. And so just really, really exciting that we're getting this much evidence. Our second story of the day is that a hungry black hole was found. And I say hungry because it has just devoured a star. So a black hole 300 million light years away in the middle of a galaxy is absolutely having a feast. A star was in the wrong place at the wrong time, basically, passed too close to this black hole at the center of galaxy. You ready for this name? ESO 583-G004. Supermassive black hole at the center of this galaxy got a little bit too close, resulting in a tidal disruption event, or a TDE. And this one currently is designated as AT 2022 DSB. And there's no way I'm remembering all those off the top of my head, so I'm going to reference those numbers and names. But we noticed this TDE because it shot bright flashes of radiation, electromagnetic radiation, out of this galaxy that was able to be picked up by the Hubble. And so astronomers saw it, pointed telescopes towards it, and particularly the Hubble was studying the large amounts of UV light that was being given off by this big tidal disruption event. And so going by the data that they're collecting and then reverse engineering and trying to simulate what happened. They used computer recreations to basically show that a star got too close to this black hole and it got caught within it, and the black hole basically just shredded it up. Yes, it turned it practically into taffy, is how I saw it described, is that it was strung out into taffy, and then it was curled around the black hole, creating what they called a donut shape around it, or an accretion disk, is how it's also known more scientifically than donut. But it created this accretion disk around this black hole of all of this star jelly, and now the black hole is just eating it all up. It's sucking all of that stuff back within it. And so, for scale of how big these things are, because I know talk about black hole stars, yada yada, but the accretion disk, that big disk of star goop that once was the star that's around the black hole, is roughly the size of our solar system, is how big that disk is. So that means the black hole is within that. It is very, very large. And these big devouring of stars from black holes are not incredibly common. Only around 100 of these events have actually been witnessed, but also most of these are in X-ray light. That's the majority of radiation that's given off is in X-ray. This one was in predominantly UV light, which makes it incredibly rare for us to be witnessing this event, because it was UV light, but also astronomers caught this happening really early in the whole feasting part of the process. And so astronomers were able to watch this for a lot longer than they usually were, gather more data and evidence, and they're going to continue monitoring. It's not over yet. It now has that accretion disk, and it's just slowly eating away at it, and astronomers are going to monitor it as it eats the rest of it for the next coming days into months. Scientists are patiently waiting for China's Zhurong Mars rover to come out of hibernation, but there's still hope left. And so I apologize for any bad pronunciations. Again, I'm barely okay at pronouncing English words, and that is the language I speak. But Zhurong, the Chinese rover that just recently went to Mars, part of its Tianwen-1 interplanetary set of missions, is kind of stuck right now, at least electronically stuck. It arrived on the Red Planet in May of 2021, so close to 2 years ago, and it landed in a spot called Utopia Planitia, which is a little bit above where the Perseverance, NASA's rover, landed in 2020. It's about 7 latitude degrees north of where Perseverance is. And the way that this rover is designed is that its power involves a butterfly-shaped solar panel array on its back, and that's how it generates its power, is by solar panel, which is how NASA even had a lot of their early rovers as well. And so it even has a really cool feature, a shaking feature, where it can vibrate the panels to try to get any dust off of the panels. We know Mars to be this big rust bucket dust wasteland. And so solar panels very commonly get covered by Martian dust, and then they start losing power. And so they have designed a shaking feature to get that off, which is really cool engineering. A little over a year ago, in May of 2020, the rover went into a kind of hibernation sleep. They went into a dormant state, as they called it, and basically shut down everything since the Martian winter was beginning, and it is incredibly frigid, harsh environment. And so they shut it down so it can better survive the Martian winter. And for reference, the average temperature on Mars drops to around negative 190 degrees Fahrenheit, which is around 123 degrees Celsius. That's the average temperature during the winter months on Mars, and that is cold enough for most alcohol to freeze if we had alcohol on there. So just to kind of put it into perspective of how cold it gets there, and that's the average. And so after this hibernation sleep, it was supposed to wake up back in December, and so it's middle to end of January as of recording this, so around a month ago it was supposed to wake up. But so far, no signal has been sent from the rover and received, and no signal has been sent and received to the rover. It's kind of just been still shut off. And so they're kind of scared that this rover is maybe not there or not doing too well anymore. But the rover should, how it's programmed, autonomously wake up when two criteria are met. When the temperature goes above 5 degrees Fahrenheit, and when it generates 140 watts of power. And so the Perseverance rover is nuclear-based, so it doesn't shut down for the winter, but it is still recording temperatures that are a bit too cold for that criteria for the rover. So the Perseverance rover is also closer to the equator, it's more south, and so it's colder where that rover is, so we think that it possibly is just a little bit of a colder winter than what was expected. It's going for a little bit longer, and so maybe the robot is okay, and it's just waiting for the criteria to be met so it can wake back up and continue on its journey. But there's also fears that because of this harsh winter conditions and the very strong winds on Mars, that there could also be a lot of dust on the solar panels, and that could also be restricting it from generating its power back again. And while I did mention there was that shaking feature to get all of that dust and whatnot off of the solar panels, the issue with that feature is that it has to be turned on and out of its dormant state in order to activate that feature to shake off the dust. But at this point, only time will tell if the rover will ever wake up from its slumber, and scientists and astronomers are just going to have to sit and wait and hope for the rover to respond. So those were our 3 main stories of the day, guys. Hopefully you enjoyed our space news. A little glimpse into what is happening in the world of astronomy this week. And so again, I pull all these stories, I research them on Wednesday and Thursday to make sure they're up to date for when I put out these episodes. And so that is all stuff that's happened within the week since the last episode of Skywalk Podcast. And so now that we have done our space news for this week, let's get into our object of the week. So our object of the week for this week of January is Barnard 33, which also goes by the name of the Horsehead Nebula, which that may ring a bell because it is a gorgeous object. Oh, I'm smiling just thinking about it. I absolutely love the Horsehead Nebula. And so let's get into it a little bit. It was discovered quite recently, honestly, all things considered, by Scottish astronomer Williamina Fleming in 1888. So yes, we've been talking about things a lot older than that. So 1888 is when this was discovered. It's actually seen on a photographic plate at the Harvard College Observatory. And so photographic plates were old styles of taking photos where you actually had a glass plate, had sort of like an X-ray paper on it for newer folk that have never heard of taking a negative. That's what you would do. You basically expose the light to it, it burns an image onto the glass plate, you close the shutter, and then you have your image once you develop it in a dark room. And so that's how old cameras worked. And so it was seen on a photographic plate. And the first description of this object was made by the American astronomer E.E. Barnard. And so you can see where Barnard 33 gets its name. And so he described it as a dark mass, a diameter of 4, on nebulous strip extending south of Zeta Orionis. And so I'll explain a couple of those a little bit later. But that's how he described it. As for our good friend Charles Messier, he did not discover this object. 1888, Charles Messier had been dead for about 71 years, well before its discovery. So Charles Messier did not discover it. That is why we are not talking about a Messier object. It is called Barnard 33, different catalog name. And so as for the origin of this object, there really isn't any. It's a dark cloud in front of a gas region that is part of the Orion molecular cloud, and behind it is a red hydrogen wall that's lit up by Sigma Orionis, which I'm saying all these words a lot of Greek words followed by Orionis. Those are different stars within the Orion constellation. And so that's just how we talk about certain stars in a more official way. So Zeta Orionis is a star, and Sigma Orionis is another star in the constellation Orion. And so here comes our stats for all of you stat-loving folk. Right ascension is 03 hours, 47 minutes, and 24 seconds. And the declination is positive 24 degrees and 7 arc seconds. Or 7 arc minutes. There we go. There's no arc seconds. It's 00. And so the Horsehead Nebula, it's what's known as a dark nebula. So it appears as a black patch in the sky. It's dark. It doesn't give off light. It's in front of a bright region of sky, and so it blocks the light coming from it and gives a silhouette of an object. And so you see the silhouette of a black cloud in front of a bright object. And so that is why it's called a dark nebula, because it appears dark. There's no light. Behind the Horsehead is a big wall of diffuse red hydrogen, and the Horsehead pops up in front of that big red wall of hydrogen. Again, part of that whole big Orion complex. And so the Horsehead appears in front of it. And so Horsehead is right near another two objects actually, NGC 2033 and NGC 2024. NGC 2023 is a reflection nebula that is near the Horsehead, and it's reflection nebula around a star. It's kind of blue in color, shining around this star. And NGC 2024 is also known as the Flame Nebula, which is another really cool object, another difficult one to see, but really, really cool object. It literally looks like how you would think of a campfire flame, how you would draw it as a kid. It is amazing. And both of these and the Horsehead are all near the bright star Alnitak. And so in the Orion Nebula, this is how you would find it. Look for the Orion Nebula and assume that Orion is standing up. That is the orientation we are looking at. And so look for the 3 stars that make up his belt, Orion's belt. And then again, if he's standing up, look from our perspective, look for the leftmost star. Or if you were Orion, it would be his right hip, right below the red star known as Betelgeuse. And so that right hip, that farthest down star in his belt, that is called Alnitak. And then I'll try not to rant, but Alnitak is the worst star that has ever existed in the universe, but it is also known as Zeta Orionis, so that's where that description comes from. Zeta Orionis is also called Alnitak nowadays. From Alnitak, directly below it is where you can find that Horsehead Nebula in that big wall of hydrogen. The apparent magnitude is positive 6.8, but do not be fooled by that number. We have talked about objects that are fainter than that in their apparent magnitude. You cannot see this with the naked eye. You will not, and I'm almost certain you cannot see this with a pair of binoculars or even a small cheap telescope. You will need a good quality telescope. You will need a big telescope to see it in any sort of amount besides feeling like your eyes playing a trick on you. It is a very hard object to see. And that's if you're trying to see it through an eyepiece. It's also hard to take a photo of. The best way to see it, though, is by taking a photo. That is the best way to see the Horsehead Nebula. Since it is a dark nebula, it does not give off light. The region behind it is the diffuse cloud, and that is what you're trying to get an exposure of in order to see it. So you need to have a very long exposure and a very sensitive exposure in order to see it, because you're looking for a dark object on a very dimly lit background. Due to the nature of this object only being discovered at the late 1800s, under 150 years ago, there's really no cultural representation of the object. I could not find any sort of cultural representation, most likely just because of technology. You couldn't see it for a very long time. You cannot see it without a good telescope. What's actually happening at the Horsehead is kind of unknown. It is just a very large dust cloud. It's interstellar dust, to be exact. And so due to this nature, there's really not much information. It's not giving off any light. Not really much is happening. It's not creating any stars, at least that we know of. And so it's just kind of there. It's just dust floating in the air. Air. I use as air quotes. But it is part of a rather large part of interstellar dusk. I talked about NGC 2023, that reflection nebula around the other star. That is actually like kind of, it actually looks kind of cool. It's almost like it's in a cave surrounded by the other part of this interstellar dust cloud. And then the Horsehead is this one part that swoops up in front of that band of hydrogen. We don't really know what's happening there, but it's just kind of floating there. It's hanging out. It's having a good time. But Horsehead is absolutely amazing. It is a gorgeous object. I love trying to take photos of it because it's a good challenge, and it is so rewarding once you actually pull it off. It is gorgeous. I would highly recommend looking up images if you are not watching this or seeing the Twitter images. But do note, like I said, Alnitak is the worst star in existence because it is so incredibly bright and it is so incredibly close to all three of these objects that I just mentioned, the Flame, NGC 2023, and Horsehead. So, if you're taking photos, be wary of this star. The best way to get a photo or to see it through a telescope is to move Alnitak out of the field of view. You want that star as far away as you can while you can still see what you're trying to look at. As soon as you get it out of the frame of view, world all of a sudden opens up. You can see so much more, it's not blowing out the image. But if you don't and you try to keep it in, you're gonna struggle. It can be done, it absolutely can be done. But just note, it is so difficult because you are now trying to expose for both a very distant, dark, hard to see object while having a super incredibly bright object directly next to it. So it can really mess things up. But just note, you can tell that I'm not a fan of Alnitak, but that is just something to note when trying to see and talk about this object, or look at this object. Let's get into our questions for this week. And so the first question was actually a YouTube comment by EJ Bing. So thank you very much for leaving this comment on one of the shorts. And they said, how the heck did Galileo know how to build a telescope? And so this was on the short of different types of telescopes. And this is a very great question, and one that I had to dive a little bit into as well, because I knew a little bit, but not too much. And so I did put a little bit of a response in the comments, but let's go into more detail. And so the first telescope that was the first telescope was invented in the Netherlands in 1608 by Jacob Matthias and Hans Lippershey. I'm really bad at pronouncing things. But it was invented in the Netherlands. And what it was basically a long quote unquote tube that had two pieces of glass in it, bent the light, and gave you a magnification of around 3 to 4 times power or magnification. And so, incredible discovery. It wasn't awarded a patent just because the patent office figured that it was too easily recreated. But I believe they actually did get a little award for it, which is kind of nice. In 1609, so 1 year later, it blew up. It became the hot thing, the hot commodity. You could buy these spy glasses in spectacle shops or glasses shops all around Europe, but particularly it started to get into Italy. And so Galileo heard about this new invention, this telescope, this spyglass, and it kind of caught his attention. He liked experimenting with things and being an instrument maker. And so he decided to try to make his own version. And he came to a very similar style. He had a long tube, couple pieces of glass, a concave, convex, and it gave him about a 3 times magnification. And so he had this telescope, and then he was like, cool, I want to improve on this. His next telescope was a 9 times power or 9 times magnification telescope. And he actually showed it off to the Venetian Senate to try to impress them, show that it could be used in military and other commercial aspects and whatnot. But the issue with these primitive technologies that he and others faced were a few different things. And so the glass tended to have bubbles in it, which not good for a clear image. and they also had a pretty noticeable green tint to the image due to iron impurities in the actual glass and whatnot. And so you would actually get this green hue over your image. Also, shaping or grinding the glass was very difficult, especially at that time, meaning that basically all of their images at that time were not clear images. They were blurry, oblong, glowy shaped stars that most of them also had haloed colored rings around them, and it was honestly quite a bad image to see. But admittedly, good enough for what they were doing, but it also wasn't a very wide field of view. It was a pretty narrow field of view, and so they couldn't even see a full moon in the telescope. It was that narrow of what they were seeing. But it didn't stop him, obviously. Galileo, with that 9 times, he started watching Jupiter, the moon's rotating, and you can get into the whole history of Galileo. But he kept improving his designs, making more telescopes, and really made it popular and famous, the invention of the telescope. And his final one was a 4-foot-long refractor that was a 30 times power magnification. So 10 times better than his first scope. So not too shabby. But yeah, while he didn't invent it, he did see, he did have examples of it because it was this new invention, and he wanted to take a crack at it. And he was a tinkerer. He was an instrumentation guy. He liked to play around with this stuff, and so he just kept improving on his stuff. Our next question number 2. Why does Sirius twinkle so much versus other stars? This one was pulled from Reddit. And so, in summary, Sirius, the brightest star in the sky, is, well, very bright and very close. A star twinkling, we always heard twinkle, twinkle, little star, because stars, if you look at it in the sky, do appear to be flashing or twinkling. That is caused by Earth, not the star. That is the Earth's atmosphere being shaky and shaking that light around. Stars are very far away, and so the light has a lot of time it needs to get over here, a lot of distance to travel. It's not as strong once it gets here, and so Earth's atmosphere just bumps it around, jostles it around, and so it appears to be dancing around. Whereas planets in the sky, they don't twinkle. They're a lot closer to us. The sunlight reflecting off of those planets travel a very short distance, are a lot more powerful. Planets don't appear to twinkle in the sky. And so that's also how you can see planets telling the difference. But that twinkling just comes from the shakiness of the Earth's atmosphere. And so Sirius is the brightest star in the sky. And that's a combination of a few different things. It is both close and really, really bright. Sirius is a relatively new star. It is actually about 20 times younger than our sun. So our sun is about 4.5 billion years old, and Sirius is about 250 million years old, which means that it has only gone around the Milky Way once in its life, versus our sun has gone around probably about 20 times since it was created. And since it is so young, it is incredibly hot. It is a very powerful, bright, blue burning hot star, and so much so that it is a lot larger as well. It is 2.5 times the mass of our sun and about double the diameter of our sun. So it is also a behemoth of a size. Its luminosity, because of all these factors, is actually about 23 times as bright as the sun. So we would be absolutely blinded in the daytime here if Sirius was in our solar system. But it is also 9 light years away, which is relatively close in the grand scheme of things. It's actually really close. But it's far enough away that it's not blinding to us, but it appears very bright. And so it actually still has a magnitude of negative 1.5. So again, it is distant, darker, fainter things are in the positives of magnitude, and brighter things like our sun is, I believe, negative 26, 27 on the magnitude scale. This is negative 1.5, so it's in the negatives. It's amazing. But due to all those factors that I just went over, all those facts, it is incredibly bright. And so the brighter an object is, the more disturbance you're going to notice. Versus a fainter thing, there's not as much light to be jostled around by the atmosphere. And so you just don't notice it as much. But Sirius is so bright that, one, it also draws your eye to it, so you notice it more than other stars. but it bounces the light. There's more light that the Earth's atmosphere jostles around. And so that's why Sirius appears to twinkle more. Basically, more light means more twinkle, in summary. Our third question and final question of this week, again pulled from Reddit, is Jupiter all gas? And so this is an absolutely great question because, honestly, not too long ago, it kind of was thought that it was just all gas. And so Jupiter is the largest planet in our solar system. It can fit about 1,300 Earths in it. It is a gas giant. That's what it's called. And so gas giant is kind of more or less what its name is, but that's probably where also the confusion comes from. And so Jupiter, admittedly, is a lot of gas. It is 90% hydrogen, around 10% helium, estimated numbers because there's some other stuff sprinkled in there, but basically a 90-10 split of hydrogen to helium. And it's big. 1,300 Earths can fit inside it, like I said, but because it's so big and it's gas and gravity, there's that much more pressure pushing down on the planet. It is huge. So much pressure in that core. And so Jupiter does have an atmosphere. It has an atmosphere, I believe, kind of similar to Earth. Like conceptually, obviously not exact, but we're just keeping it nice and easy for everyone to understand. So atmosphere, think of like Earth, except it's just full of hydrogen and helium gas. And that atmosphere is where you see all the fun clouds and swirls and all the really cool definition within Jupiter is all within that atmosphere around it. And then as you go deeper, there's more pressure and pressure on that gas. You start getting some really funky stuff happening, some weird transition stuff. Not going to get into that. You have things that are both liquid and gas and neither, sometimes all at the same time. Again, we're not going to get into that. But basically, once you pressurize gas, it can turn into a liquid. And so we're obviously not 100% sure because we can't go into Jupiter, but our best guess right now is that the center of Jupiter, its core, while Earth has this liquid iron core, Jupiter has a liquid metallic hydrogen core. So basically all the hydrogen compressed so incredibly that it is this liquid, very highly conductive material. And it has a viscosity of kind of similar to water. Don't want to touch it though. It's hotter than like lava, magma. So it is this kind of liquidy hydrogen core is what the center is. And so, yeah, in summary, it is not completely gas. A good chunk of it is gas, but then the core of it is this sort of liquid metallic hydrogen. So very good questions this week. And again, I appreciate the YouTube question as well. If you guys want to be part of the Q&A for next week, join the live stream live. We do it on Thursday nights, but also leave comments on this episode or on Twitter, on TikTok, on the YouTube shorts. I will be watching all of those. And so if you have a question, leave it. I will pick the best ones, or I will pick the 3 that are there, and we will answer them in the next episode. And so let's get to our final segment, Picture of the Week. And this is without a doubt the one I was going to pick. Had it since I saw it. And so there is an enormous gas cloud over Andromeda. This is the image. Again, for those on audio only, go ahead and check out the image on Twitter or just search up big cloud over Andromeda Galaxy. I'm sure you'll see it. Amateur astronomers Marcel Dreschler, again, pronunciation, Xavier Strautner, and French astronomer Jan Sainty. Yes, I had to refer to my notes for those because there was no way I was going to remember those names. But those 3 have probably taken one of the most incredible images I've ever seen, and absolutely by far the most incredible image of the Andromeda Galaxy I've ever seen. Yes, I'm saying this beats Hubble, because it is gorgeous. And this image and story was first published in AAA's journal, American Astronomical Association, I believe is the abbreviation. But this image is interesting. You see the Andromeda Galaxy and neighboring galaxies, and you see this big red cloud making up most of the image around it. But very confusingly, there is this big blue arch going over top of the Andromeda Galaxy. Absolutely huge, especially if you're comparing it to the size of a galaxy. Absolutely huge. Tens to hundreds of thousands of light years across. And so this enormous region is an O3, or oxygen region, floating above this galaxy. And you think that we have seen everything there is to see, especially the stuff close to us. But this just shows that we haven't. It has never been seen before. But these guys really focused on using O3 filters, so blocks out all light except for O3. And after they took enough data, this gas started to appear, this big formation. And so at this time, since this is new, literally just within the last week, we are not sure if this is just an optical illusion of something in the Milky Way that is in that direction, and so it looks like it's over the Andromeda, or if it's actually something over the Andromeda Galaxy. Again, we're not really sure, but scientists are absolutely baffled by this, and so I'm sure we're going to have things like the Hubble and other big land-based telescopes and research telescopes pointing that way, and we're going to learn about what this is, because I can probably speak for a lot of people that this is huge. This is so cool. And so the object, that blue O3 region, has been aptly named called Stratner-Drechsler-Sainte Object 1. The names were hyphened in between. Or you can shorten that down to SDSO-1. And so that's the object name. But again, two of the three guys, the two guys that actually discovered it, were amateur astronomers. They're taking photos, and then they noticed it, and then got the French astronomer to join with them and start taking more data. And so, just absolutely incredible. Amateur astronomers discovering very important scientific things like this. It just, good job, guys. Absolutely great job. Thumbs up. Good job, and a good representation of the amateur astronomy and amateur astrophotography community. Absolutely love it. All right, guys. Well, that's about everything I have for us this week. Once again, I want to absolutely, from the bottom of my heart, express my gratitude to everyone that is helping us start to build this community up to a much bigger level. And also for you guys to put your trust in me to bring you as accurate space news and as entertaining space news and entertainment as I possibly can. So thank you guys so much. You mean the absolute world to me. And again, I can't do this without you, so thank you. But as always, some quick reminders before we get out of here. A reminder about the other content and areas for you to communicate. YouTube Shorts will continue to go up alongside the TikTok videos. Those will be together. Reddit and Discord are the easiest ways to join this community and the best ways to talk to each other and to me directly, and to begin interacting. The Skywalk website is where you can find information about this podcast, the merchandise, and also a blog. I'm attempting to try to figure out how to blog, so bear with me while I attempt to learn to blog. But you can also stay up to date, of course, on Twitter at SkywalkPod. A reminder, too, please, if I can ask one thing of you guys, is to rate 5 stars, like, comment, and subscribe. You guys have been absolutely great with interacting with the YouTube Shorts, and it means the world to me. And if we can also share that love into the podcast itself, that is going to be how we fight all these algorithms that make up today's world. All that interaction, just showing that the audience is engaged, is really how the algorithms like to help promote things like this content and those YouTube Shorts. So you guys have already started doing it, and I've noticed that. So thank you guys, and please continue to do so. It not only makes me happy, but it also makes YouTube and algorithms happy. But the best way for us to actually grow this podcast and community itself is by word of mouth, of course. So today, let's go ahead and tell your favorite astronomy-loving friend to go listen. So whoever you know, your closest friend that loves astronomy, go tell them to listen to this podcast. All right, guys. I have been Gavin Moriarty, your host for the Skywalk Podcast. This has been the Skywalk Podcast Season 2, Episode 2, bringing you your weekly dose of space news and facts. You have all been wonderful listeners, and I will see you all next week with another episode.